Hey guys, Mr. Riz again here, and I'm going to help you guys out on the second part of the 2.1 notes. So the second part is actually really short. We got this one problem here, but we'll spend some time going over the tougher problems on the CYU today. So what we're going to do today, our goal is to continue what we did where we can find the equation in the vertex form, but then what we're going to do is turn that back into the generic quadratic equation. And it isn't too tough. There's nothing really new that you guys have to worry about. It looks scarier than what it is, but all we're doing is just going to simplify or evaluate it after we put it into the vertex form. So we got this example here. The height of a thrown ball is a quadratic function of the time t, or the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is at 120, and the path of the ball includes the point 0.04. What is the expression that defines this function? Write the quadratic equation in the vertex form and in the form y equals ax squared plus bx plus c. So let's first do what we did yesterday, is to get this equation into the vertex form. So if we wanted to get into the vertex form, we have to use the vertex, which tells us h and k, and the point x and y. So vertex form, we'll do it over here, vertex, is y equals a times x minus h squared plus k, where we have to find a, h, and k. Well, lucky for us, h and k are already given to us. They're 1 and 20, but a is not. So we're going to use our x and y values with our h and k in this expression to find a. Just like when we do y equals mx plus b, when we plug those values in to figure out b, we'll do the same thing here to figure out a. So let's set this up. All right, our y is 4, a we do not know, x is 0, minus h is 1 squared plus k is 20. So we set this up, we get a equals, or 4 equals, if I go ahead and add that, that's negative 1 squared plus 20. So 4 would equal, okay, negative 1 squared is a positive 1. So really this is just a positive 1a, or just a plus 20. And we'll minus the 20 over, so we get, okay, negative 15 equals a. So the vertex form of this equation is y equals a, which is negative 15, times x minus 1 for h squared plus 20. Okay, now the question is, how do we get it into the generic form? How do we get into y equals ax squared plus b? Well, if you look here, if you just notice, there's just no parentheses. So what we're going to do is to distribute this and solve. I'm going to try to do my work over here. So if I have y equals negative 15 times x minus 1 squared plus 20, what I'm first going to do is take care of the square. I can't simplify the inside parentheses, that's just x minus 1, but I could square this. Now, be careful. Do not just distribute this and make this x plus 1. We have to remember that this is negative 15 times x minus 1 times x minus 1. And we still have our plus 20. Squaring means multiplying it by itself. So we want to do this because we have to, what I call FOIL, or double distribute. We have to multiply the first numbers together, then the outer numbers, then the inners, and the last. So let's ignore the negative 15. Let's ignore the 20. Let's take care of all the distribution here. If I got x times x, that's x squared. X times negative 1 is a negative x. Negative 1 times x is also a negative x. Negative 1 times negative 1 is a positive 1. So what this ends up becoming is negative 15 times x squared minus 2x plus 1 plus 20. So now we squared it. We just took care of that. It took a couple steps. Now let's distribute the negative 15 to those three things. So we get a negative 15 x squared. All right, if I times negative 15 times negative 2x, that becomes a positive 30x. And then negative 15 times 1 is a minus of 15. And we have our plus 20. Now finally our plus 20 gets involved here. We can combine it with the negative 15 and the 20, and we would get a final answer of negative 15x squared plus 30x plus 5. So both of these are the same expression. This one here is vertex form, which is really easy to graph. This one is our generic quadratic equation, which we'll use later on in this chapter to help us find other key pieces. Okay, so this wraps up the notes. We could do more problems in our notes, but what I'm going to do is go through the CYU and make sure you guys can understand it. So we're going to see if we can do the problem like we did yesterday. If we can, we'll skip it, and if it involves today's stuff, we'll do it together. Okay, so the first question in the CYU2 is the function g of x is x plus 2 squared plus 4 is a parent function of x squared, which is, okay, so this is what we talked about yesterday. So can you remember what this does yesterday? And you select the ones that apply. All right, next one here, where are the domains and the ranges of the real function? All right, so put this into Desmos, look at domain. We've done that before, so nothing new here. Okay, what we did yesterday, h and k. So we can go through here. This is h, k, x, and y. Plug this all in vertex form. So they want you to leave this in vertex form. All right, so here is the question that we need to do today. Which of the following is the equation in generic form? So let's go ahead and let's do it in vertex form. We'll go through this problem together. We need to find the vertex here, which it definitely looks like this vertex is at the point, we had a guess here, 2, and then let's see, that's 45, and pick another point. All right, I can clearly see that this is at the point 5, 0, right? So let's pick our h and k, and this is our x and y, and plug it into y equals a times x minus h squared plus k. So y is 0, a we don't know, x is 5, minus h is 2 squared plus k is 45. So we get, not a, 0 equals a times, that'd be 3 squared plus 45. So 0 equals, let's see, a would be 3 squared, so it'd be 9a plus 45, minus the 45 over, divide by 9. All right, so a would equal negative 5. So the vertex equation is y equals negative 5 times x minus 2 squared plus 45. What we just need to do now is to take this equation and turn it into generic form. So we're going to square the x minus 2, so we're going to leave the negative 5 alone. We're going to write out x minus 2 twice. And leave the plus 45 alone. All right, so let's distribute the x minus 2's. All right, x times x is x squared. X times negative 2 is negative 2x. Negative 2x, or negative 2 times x is negative 2x. Negative 2 times negative 2 is a plus 4. All right, we've taken care of that distribution. We also need to distribute the negative, oh, we'll simplify it. I guess we didn't have to, but we'll do it. It makes it easier. This becomes x squared minus 4x plus 4. We're going to distribute the negative 5 here, and we get a negative 5x squared. All right, negative 5 times negative 4 is a plus 20x, and then we have a minus 20 plus 45. Just need to clean that up here. So we get y equals negative 5x squared plus 20x, and then doing this together, minus 25. Oh, no, plus 25, because that's positive 45 minus 20. All right, and that's choice D here. Alrighty. All right, last problem here. All right, the parent function of transfer x squared, the graph is translated down right to the right 3 and down 5. Which equation? Okay, so this kind of combines what we did last time and this time. So if we're going to move it to the right 3, this graph is going to change to y equals x minus 3 squared, and we make a move down 5 minus 5. So here's the new equation of the graph. I'm moving it to the right 3 and down 5. Now what we need to do is put this in generic form. So if you want to think there is a 1 here, it really doesn't matter. What we need to do is square that term. So let's write out the x minus 3 twice. We'll leave the 1 on the outside alone, which isn't going to change anything. And we'll leave the minus 5 alone, which won't affect anything till the very end. So let's distribute this x's here. X times x is x squared. X times negative 3 is a negative 3x. Negative 3 times x is also a negative 3x. Negative 3 times negative 3 is a positive 9. Now we have our minus 5 here. We can go ahead, combine these like terms. We'll combine these into one step. We get an x squared minus 6x and then a plus 4. That looks like choice B. So hopefully that helped you guys out with the CYU, and you guys can do the other problems. All right, so this wraps up 2-1. We'll start 2-2 tomorrow, guys. Have a great day.